The countries surrounding the Persian Gulf are often regarded as both fortunate and vulnerable because of their enormous oil and natural gas wealth. Millions of years of geological activity transformed this relatively small region into the world's most important energy center. As a result, whenever tensions rise in the Persian Gulf, global oil prices often react immediately. Energy markets become volatile, and governments begin assessing the potential economic impact. The sheer scale of the region's hydrocarbon reserves continues to amaze petroleum geologists. Around the Persian Gulf are more than 30 supergiant oil fields, each containing at least 5 billion barrels of recoverable crude oil. Its production capacity is just as remarkable. Many oil wells in the region produce 2 to 5 times more oil per day than some of the highest producing wells in the North Sea or Russia. Modern geology shows that several conditions are necessary for a region to become exceptionally rich in oil and natural gas. Rocks must be able to generate hydrocarbons, store them underground, and preserve them for millions of years. The Persian Gulf possesses these conditions at almost ideal levels. Combined with relatively low extraction costs, this has made it the world's leading conventional petroleum province. Humans have known about naturally occurring hydrocarbons in this region since the Persian Gulf formed after the last ice age, when rising waters flooded the area roughly 14,000 to 6,000 years ago. Natural oil and gas seepages appeared across river valleys and low-lying land throughout the region. Long before the beginning of the Christian era, ancient civilizations were already using bitumen, a heavy form of petroleum, as mortar in construction and to waterproof wooden boats. The modern petroleum era in the Persian Gulf began in 1908, when the first major oil discovery was made in western Iran at the site of a well-known natural oil seep. Exploration accelerated during the 1950s and 1960s, revealing petroleum reserves on a scale never before seen. Although major oil and gas fields have since been discovered in regions such as Western Siberia and the Permian Basin in the United States, none has matched the Persian Gulf in either the size of its conventional reserves or the exceptionally high productivity of its oil fields. The extraordinary energy wealth of the Persian Gulf begins with its unique geological location. The region lies where two major tectonic plates meet, the Arabian Plate to the south and southeast, and the Eurasian Plate to the north and east. These plates have been colliding for approximately 35 million years. Although their movement is extremely slow, it has dramatically reshaped the Earth's crust. Rock layers were folded, fractured, and buried deep underground, where intense heat and pressure created the conditions needed for oil and natural gas to form. The two sides of the Gulf developed in different ways. On the Iranian side lies the Zagros Mountain Range, which stretches about 1,800 kilometers, 1,100 miles, from the Gulf of Oman to the Turkish border. The Zagros Mountains form part of the vast alpine Himalayan mountain system. Over the past 60 million years, collisions between the African, Arabian, Indian, and Eurasian tectonic plates created the heavily folded and fractured rocks that characterize the region today. The Arabian side followed a different geological path. Instead of extensive folding, tectonic pressure deformed the deep crystalline foundation, known as the basement rock, creating enormous dome-shaped underground structures that extend across dozens and sometimes hundreds of square kilometers. At the same time, erosion from the rising Zagros Mountains filled the basin beneath the Persian Gulf with thick layers of sediment. Deep within this basin, temperatures and pressures eventually reached the conditions required to generate oil and natural gas, creating one of the world's most favorable geological environments for hydrocarbon formation and storage. Source rocks, where the oil came from. The oil and natural gas beneath the Persian Gulf originated from the remains of microscopic marine organisms, mainly phytoplankton and zooplankton, that lived in ancient seas hundreds of millions of years ago. After these organisms died, their remains settled on the seafloor, mixed with mud and sediments, and were gradually buried beneath thicker layers of rock. Over millions of years, increasing heat and pressure transformed this organic material into crude oil and natural gas. Geologists classify a rock as a high-quality source rock when it contains at least 2% organic matter, providing enough biological material to generate significant quantities of hydrocarbons. The Persian Gulf contains an exceptional number of these source rock layers. Many are unusually thick, widespread, and rich in organic material, making them among the most productive petroleum source rocks in the world. Important examples include the Hanifa and Tuwaiq formations along the Arabian Gulf coast, both deposited during the Jurassic period about 200 to 145 million years ago. Another major source rock is Iran's Kazdumi Formation, which formed during the Cretaceous period, approximately 145 to 66 million years ago. These formations typically contain between 1 and 13% organic matter, while some locations contain even higher concentrations, providing the vast amounts of hydrocarbons that now lie beneath the region. How the oil and gas became trapped. Generating oil and natural gas is only part of the process. For giant petroleum reserves to form, those hydrocarbons must also be trapped and preserved underground. The Persian Gulf contains some of the most efficient natural trapping systems found anywhere in the world. Folded rock layers and enormous underground dome-shaped structures prevent oil and gas from escaping, allowing vast reserves to accumulate over millions of years. One of the best examples is the Zagros Fold Belt. These giant folded structures, clearly visible in satellite images, contain hundreds of billions of barrels of oil and trillions of cubic meters of natural gas. Petroleum maps of the region reveal long, narrow structures stretching from northwest to southeast. These elongated formations mark the massive underground folds that contain hundreds of oil and gas reservoirs extending from southern Iran into northeastern Iraq. On the Arabian Plate, giant dome-shaped structures created equally impressive reservoirs. Among them is Saudi Arabia's Ghawar oil field, the world's largest conventional oil field, containing more than 70 billion barrels of recoverable crude oil. Another remarkable example is the South Pars North Dome gas field, which holds at least 46 trillion cubic meters of natural gas, an amount of energy equivalent to more than 200 billion barrels of oil. The region's reservoir rocks also contribute to its exceptional productivity. Most are made of limestone that has been partially dissolved over geological time, creating interconnected spaces through which oil and gas can flow more easily. In the Zagros region, hydrocarbons also move through fractures and faults created by millions of years of tectonic activity. Outstanding examples include the Arab D reservoir in Ghawar and the Asmari limestone across many Zagros oil fields. These formations extend across hundreds, and in some cases thousands of square kilometers, making the Persian Gulf the world's most remarkable conventional petroleum system. Future potential. The Persian Gulf's unique geology has created an extraordinary concentration of energy resources. Although the region covers only about 3% of the Earth's surface, it contains nearly 50% of the world's conventional oil reserves and around 40% of its natural gas reserves. Despite more than a century of exploration and production, scientists believe significant resources may still remain undiscovered. In its 2012 assessment of the Arabian Peninsula and the Zagros Mountain Belt, the U.S. Geological Survey, USGS, estimated that the region could still hold around 86 billion barrels of undiscovered oil and approximately 9.5 trillion cubic meters of natural gas, in addition to already known reserves. Future output may also increase as drilling technology continues to improve. Techniques such as horizontal drilling and hydraulic fracturing, developed and refined in the United States, have made it possible to recover oil and gas that were once too difficult or too expensive to extract. Today, Saudi Arabia and the United Arab Emirates are testing these methods in some of their oil fields. While it is still too early to know how effective they will ultimately be, current studies suggest they could increase production from certain reservoirs and extend the productive life of several major fields. The Persian Gulf became the world's leading oil and gas region because millions of years of geological processes created almost ideal conditions for generating, trapping, and preserving hydrocarbons. Rich source rocks, high-quality reservoir formations, massive underground traps, and the combined effects of heat, pressure, and tectonic activity all contributed to this exceptional petroleum system. As a result, nearly half of the world's conventional oil reserves and about 40% of its natural gas are concentrated beneath a region that covers only a tiny fraction of the Earth's surface. More than a century after the first major oil discovery, the Persian Gulf remains the world's leading conventional oil and gas province. And geological evidence suggests that substantial undiscovered resources may still lie beneath its surface. So, as the world changes and energy technology continues to advance, can the Persian Gulf maintain its position at the heart of the world's energy system? Share your thoughts in the comments and subscribe to USMag for more in-depth documentaries and analysis.